Hello everyone, I am Amit. Today we will discuss what is correlation. In last video in linear regression, we have seen adjusted R square. If you add any irrelevant feature, R square value may remain same or gets increases. But when we discuss R square adjusted, if you add irrelevant feature, the adjusted R square value will get decreases. If you are adding related feature, or you can say significant feature, then R square adjusted value will get increases. So we will see how we how we check the relation between the variable. So that is correlation. So what is correlation? Correlation explain how one or more variable are related to each other. These variables can be input data feature which have used to forecast our target variable. Correlation is statistical technique which determine how one variable moves change in relation with other variable. It gives us idea about degree of relationship of two variables. It's a bivariate analysis measure which describe the association between different variables. In most of business, it's useful to express one subject in term of its relationship with other. Like if you are adding features, you are gathering data for any analysis, you will be focusing on relevant data, right? If you are calculating data of a shopping mall, that how what is the sale, and if you are adding a color, that what is the building color or number of vehicles coming, this may be not relevant as much. The financial detail will be relevant, right? So we need to check the correlation between the variable, relation between the variable. If two variables are closely correlated, then we can predict one variable from other. Correlation plays a vital role in locating the important variables on which other variable depends. Is used as the foundation for various modeling techniques, right? Like R adjusted R square. Proper correlation analysis leads to better understanding of data. Correlation contributes toward understanding of causal relationship between, if there is. Positive correlation. Two feature variable can be positively correlated with each other. It means that when the value of one variable increases, then value of other value also gets increases. So you can see the value of x are increasing 1, 2, 3, 4, and you can see the y value is also increasing 1, 2, 3, 4, right? Negative correlation. Two features are can be negatively correlated with each other. It means that when the value of one variable increases, then the value of other variable decreases. So we can see here when x is equal to 1, y is 4. When x is equal to 2, y is equal to 3. So when x is increasing, the y is decreasing, right? So this is negative correlation. If both are moving in same direction, it means positive relation. If both are moving in opposite direction, it means correlation, negative correlation. And when no correlation means you are not able to figure it out whether once you increase a variable, will it decrease or increase the other variable. You can see the below example. There are two variable, right? So it is not easy to formulate any relation between them. This is no relation between them. So we will see how we can do it in our analysis or in data preprocessing. So you must understand that data preprocessing is art. You cannot say it's a math and technique, and I'll or write or somebody can write 10 rules that you will use and you will follow and you will get the better result. You have it depends on the data and how do you handle the data, how do you do the pre-cleaning, pre-processing of data. So earlier we have seen Boston data set in linear regression. If you haven't done it, kindly go through that. Okay, so I have imported Boston data set. Let's run the output till here. So you can see I have created data frame using all the features. You can see they are 13 plus 1. This is our target value. Okay. Now we'll see relationship between them. So how we will calculate first correlation. So df dot core. it will calculate the correlation, and correlation value will be from -1 to +1. If it is from -1 to minus 0.5, it means it is highly negatively correlated, or you can say negative correlation, or strong negative correlation. If it is from 0.5 to 1, it means there is a positive, strong positive correlation. If it is from nearby 0, we can say there is no correlation. So we'll use SNS heat map to print the output. As you can see in the correlation graph, here you can say this is our output. So we will check the correlation with others. So you can see from ABDV, if we check correlation between MEDV and MEDV, it is 1, because this is the same value. If you'll increase, it will increase. If you'll decrease, it will decrease. But if you'll check with LSTAT, so you can see this is 0.74, minus 0.74. It means negative correlation. If we'll check with the B, you can see 0.33. It is positive, but the impact is less. You can see minus 0.51. You can see, right, this value and MEDV, where it crosses, this is a value, right? And we can see 0.25, DIS relationship is 0.25. This is a relationship with 0.7. Okay, so values are from -1 to 1, so you can easily verify it, right? Okay, if you are calculating correlation with the same variable, it will be obviously 1. So we can see we have negative and positive both. So now for this, we will take only strong correlation, which will be below -0.5 and above 0.5. So we will take this one, which is -74, -51, and 0.7. So let's take them. We can see the value of core, which we have already calculated it using the df dot core. It's the same value. You can see we can verify for one. MEDV with crime as -38, -38, or you can say 39. Okay, hope this is clear. Now we'll calculate what are the features which correlation value is greater than 0.5 absolute value. So we have got 1, 2, 3. So we have three variables, right? RM, PT ratio, L stat. So now we will calculate correlation between them. We have three variables. Now we'll check whether these variables are related to each other. Like we have age and date of birth. You can see both are related to each other, right? If you have date of birth, you can calculate the age, right? So if you have a two variable which does the same trick, so we can remove one variable. We can remove age and we can just have date of birth, right? So in the same way, we can calculate it here, like if you have a height in feet and inches, so both are representing the same thing, we can skip one, right? So now we will check the correlation. So we'll use this print df lstat and pt ratio, rm and lstat. So we can see rm and lstat are relative, right? So we can remove one. Now we'll check the value Lstat and Rm. So 0.69. This is 73. So we'll take Lstat and we will remove Rm. So in Y we will just take MEDV. Okay. In X we will drop other features. So we are just taking Lstat and PT ratio. Okay. We can print and we can verify that. Yeah. We will print Y as well. Now we have taken X train X test using train test split. Now we'll perform linear regression. We have calculated the Y prediction. You can see this in earlier video as well. And now we'll calculate the performance measure values. You can see our MSE value is 29, our MSE value is 5.39. So in this we have just taken the cutoff, or you can say the threshold is 0.5, where we have taken the strong relation. Now we'll calculate it again. Now we'll calculate again correlation. So you can see the correlation table. Now we'll take the point 3. as a threshold. So we will just remove this one, which is having 0.25, 0.18 chas. So we will remove chas and this. So we can check correlation target value 0.3. Okay, we have taken absolute value if you haven't seen it. Okay, so we can see chas and this, which we already seen using graph, and we can calculate it using map. Uh, Now we'll drop chas, rm, and this. We'll remove three: chas, this, and rm. So rm was related to LSTAT. Last time we have seen it, right? Now we can calculate the value x and y. So next we have dropped MEDV and we'll get x, and then y df dot MEDV, which is our output value. We can check. We'll print y as well. Now again we will calculate performance. So now MSE value is 26 and RMSE is 5.14. Earlier it was 5.39. So you can see there is it has been increased. That's why I was saying it's art. Like data preprocessing is art. We have selected few variable, few features, then we got higher value. When we selected more relevant features, we didn't focus on a strong relation. We just focused on the relation, and we got the better result, right? So this is art, and we can use correlation and understand the relationship between variables, one and two variables. Hope this is clear, and thanks for watching my video. Like and subscribe my video. We'll meet again. Till then, bye bye.